Good morning. So yesterday we have given a problem. So in that problem, we discussed to calculate a specific gravity, specific weight and density of 2 liter of fluid which weighs 14 Newton. So this was the problem. I think you have gone through the problem. And so first one, specific weight. How to find the specific weight? So it is solved here. Specific weight is nothing but it is the weight of the fluid divided by volume. It is the ratio of weight to the volume. Weight will be in Newton and volume will be in meter cube. Now in this problem, weight of the fluid is given, that is 14 Newton. Okay, so substitute that value here in the numerator, and volume is given, that is 2 liter. 2 liter means 2 into 10 to the power of minus 3 meter cube. 1000 liters is equal to 1 meter cube. Therefore, conversion will be liter to meter cube, conversion will be 10 to the power of minus 3. Therefore, 2 multiplied by 10 to the power of minus 3 will be in terms of meter cube. Okay. Therefore, 14 divided by 2 into 10 to the power of minus 3 will gives you the specific weight of the fluid, that is 7000 Newton per meter cube. Next one, density. So we know that gamma is equal to what? Rho into G, right? So we have gamma, specific weight, and we know the value of G. Now you can find out rho. Rho is equal to this specific weight gamma by G. Now whatever you have found here, that is specific weight, that when you divide it by acceleration due to gravity, then you will get the density in kg per meter cube. So this is 7000 divided by 9.81 will gives you the 713.5 kg per meter cube. That is the second answer. The third one is specific gravity. So specific gravity is nothing but it is the density of the fluid divided by density of the standard fluid. So this is what we have discussed. So this is nothing but specific gravity. Okay, or else this is also the weight density of the fluid divided by weight density of the standard fluid. Both also you can do. Okay, so here standard fluid here in the form of liquid, if you take the standard fluid density as 1000, then gamma of the standard fluid will be 1000 into 9.81. So both the equation you can use 1000 into 9.81. Okay, now if you use this equation, then so whatever the answer you got in this one, that is 713 divided by 1000 you have to do. If you use this equation, then 7000 divided by 1000 into 9.81 you have to do. So both will give you the same answer, that is 0.7135. So specific gravity is dimensionless parameter. So we numerator and denominator physical quantities, physical dimensions are same. Therefore, we don't get any units for the specific gravity. So the specific gravity of the given fluid will be 0.7135. So this is what we have solved the problem. So I think you also solved this one. This was the assignment I have given yesterday, and I think you have solved. Hope you got the same answers. If you have not got the same answer, okay, kindly take a screenshot or note down. Okay, then this is the answer. These are the three answers. So like that, there is one more problem. So this I will give you as an assignment. These two you can solve. Okay. Next, I will discuss about viscosity. So far, we have discussed four properties of the fluid. One is density, and another one is, second one is weight density or specific weight. Third one is this one, specific gravity. And fourth one is, what is the fourth one? Specific weight, mass density, weight density, specific volume, and specific gravity. So four we have discussed. The fifth one is very important, that is called as viscosity. So what do you mean by viscosity then? So it is nothing but it is a viscosity is nothing but it is a property by virtue of which the fluid offers resistance for its motion. Okay, so it is the property by virtue of which the fluid will not easily flow, so it will offer some resistance. So that property is there for every fluid, so that is called as viscosity. Okay, so the same thing he has told, it is a property of fluid that offers resistance to its flow. Now here we are having a small derivation to get the expression for the viscosity. So now for that derivation I will consider one small experiment. Here one fluid is flowing upon a surface. So this fluid, okay, flow over the other layer of the same liquid at a distance dy apart, let us say. So this figure is here. Now this is the surface. On this the fluid, this is the fluid which is flowing. The fluid will have the velocity u at y and velocity u plus du at another height, another layer, which is equal to y plus dy. Now using this expression, using this experiment, we are going to discuss the expression for the density, this one, viscosity. Now as per this one, we already studied that shear stress between these two layers, there are two layers I have considered. One is this layer and another one is this layer. Between these two layers, when they move, there is a shear stress. Shear stress means, so one force will act in this way and another force will act in this way, and both the forces are not collinear. So that type of force is called as force induces a stress, that is called as shear stress. So this shear stress is nothing but rate of change of velocity divided by distance between layers. Means it is the ratio of rate of change of velocity between these two layers and distance between the layers. So now you see that one layer is having the velocity u and another layer is having the velocity u plus du. Okay, so now what is the change in the velocity? Here it is u, here it is u plus du. Okay, so the change in the velocity is nothing but du. Now distance between the layers. Okay, now distance between the layers is what? Between these two layers, u is at a level of y and u plus du is at a level of y plus dy. Therefore, the distance between these two layers is dy. Now I have considered that one also. Therefore, shear stress tau is equal to u plus, sorry, du by dy. Now tau is equal to mu into du by dy. So this is the expression by adding a proportionality constant I got. So this proportionality constant mu, what I have multiplied to the above expression and removed this proportionality symbol and put the equal sign. So this mu is nothing but it is called as viscosity. So now rearranging this equation, I will get mu is equal to tau, that is shear stress between two layers of the fluid, and du by dy. Okay, so the constant of proportionality is known as coefficient of dynamic viscosity or viscosity, and it is represented by the Greek letter mu. Okay, so we have done a small experiment where the fluid is flowing upon a surface. The fluid velocity is u at y, at a height y, u plus du at a height y plus dy. So change in the velocity by change in the distance between layers is called as shear stress du by dy tau, adding a proportionality constant mu, sorry, not adding, multiplying a proportionality constant for the above equation. I can remove the proportionality symbol. Now that proportionality constant, it's nothing but it is the viscosity. So rearranging this above equation, mu is equal to tau into du, tau divided by du by dy. So this is the expression for the viscosity. Okay, so mu is nothing but it is a Greek symbol or Greek letter which represents the dynamic viscosity. So this is not kinematic viscosity, it is dynamic viscosity. Now the unit of this one, that is the dynamic viscosity, we have to discuss. So I will go as per again the same equation, shear stress divided by change in the velocity divided by change in the distance. So this is the equation, mu is equal to what? Tau divided by du by dy is the equation for the dynamic viscosity equation. Okay, now the same thing I have written here. Shear stress is nothing but force by area. Du is nothing but change in the velocity or velocity. Velocity is nothing but length by time multiplied by 1 over length. 1 over length means that nothing but dy. Again, simplifying this one. Okay, length you can cancel. This time when you take it above, it will come here. Force into time by area. Okay, force into time by area. So this denominator vanishes. Only force by area multiplied by time will be there. So now area is nothing but length into length, that is length square. So force is nothing but a Newton, time is nothing but second, and length is nothing but length square is nothing but meter square. Therefore Newton second per meter square is the unit of the dynamic viscosity. So it is also called as Pascal second. We know that Newton per meter square is what? Pascal. Okay, so it is also expressed in Pascal second. Newton second per meter square is also nothing but Pascal second. So there is a MKS unit also derivation, but we are studying only SI unit. We don't need MKS units. Therefore, Newton second per meter square or Pascal per second SI unit of the dynamic viscosity is enough. So if you derive in the same way, the MKS unit you will get kg force second per meter square is the MKS unit of the dynamic viscosity. Now the CGS unit is very popular for dynamic viscosity, that is called as poise. So often in problems you will get the unit of this dynamic viscosity in the exams also in terms of poise. So when you get in terms of poise, at least you should know how to convert it to the SI units. Therefore, this is the conversion. Please note down this one. One poise means poise is CGS unit. One poise is equal to 1 by 10 Newton second per meter square or 1 by 10 Pascal second. Okay, so 1 centipoise is nothing but 1 by 100 poise. 1 poise is equal to 100 centipoise. So these three conversions you need to note down. Once again, I will tell you, 1 poise is nothing but 1 Newton second per meter square divided by 10. That is 1/10 of the Newton second per meter square will be 1 poise. Okay, so 1 centipoise is equal to 1 by 100 poise. 1 poise is equal to 100 centipoise. So just like 1 meter is equal to 100 centimeter, 1 poise is equal to 100 centipoise. 1 centipoise reverse is 1 by 100 poise. So we again derive here one more viscosity term, that is called as kinematic viscosity. It is based on the dynamic viscosity term. Now you see that kinematic viscosity nu is represented by the symbol nu, that is nothing but it is a ratio of dynamic viscosity by density, that is mu by rho. It is similar to that of previous one. It is divided dynamic viscosity. When it is divided by density, then you will get a kinematic viscosity. That is nu is equal to mu by rho. Now again, derivation of this one. So SI unit of dynamic viscosity, directly I will put SI unit Newton second per meter square. See, Newton second per meter square is what? So SI unit of dynamic viscosity divided by SI unit of density. So here we have derived Newton second per meter square. So that the same thing I'll put here, Newton second per meter square divided by density kg per meter cube. So simplifying these things, Newton is kg meter per second square multiplied by second per meter square, the left out things. Now you just cancel whatever the things you can cancel. Okay, now after simplification you will get meter square per second. Okay, so just 1 second will be cancelled. Okay, here 1 meter and 1 meter will be cancelled. Okay, if you take this above here, then it will be meter cube. So this meter cube will become meter square after cancelling one more meter. The left out thing kg will cancel. Again meter square is left out, divided by here 1 second is left out. This I have taken in the numerator. So meter square per second is the unit of the kinematic viscosity, which is derived in this fashion, right? Okay, meter square per second. Again we have the popular CGS unit. For that we use the unit CGS unit as Stoke. 1 Stoke is equal to 10 to the power of 4 minus 4 meter square per second. So these conversions you should remember, because in the exams most often they ask to solve you the problems by giving the data in terms of either Stokes or Poise. Therefore you need to be very careful and you have to convert. If it is in a Poise or Stoke, dynamic viscosity and kinematic viscosities, that you have to convert it into SI units. So these are the conversion. 1 Stoke is equal to 10 to the power of 5 minus 4 meter square per second. Similarly, 1 Poise is equal to 1 by 10 Newton second per meter square. These two equations you have to remember so that you can convert these things very easily. Okay, and again, like the previous one, 1 centistoke is equal to 1 by 100 stoke, or 1 stoke is equal to 100 centistoke. It is a very common thing. So these things you have to remember so that you can always convert. If it is in the exam, they have given in CGS units of dynamic viscosity and kinematic viscosity in terms of Poise or Stoke, then Poise should be converted into Newton second per meter square and Stoke should be converted into meter square per second. Okay, so these are the two things, that is viscosity, dynamic and kinematic viscosity. Both are same property of the fluid, but they are expressed in a slightly different manner with a different notation and different units. Okay, so next one, Newton's law of viscosity. So it is not a property, it is a law related to the viscosity. So this Newton's law states that shear stress on a fluid element layer is directly proportional to the rate of shear strain. This we have already used. Tau is equal to du by dy. This is what we call as Newton's law of viscosity. So this equation for the derivation of dynamic viscosity, what we have used, this is already nothing but it is a Newton's law of viscosity. So in this, the constant of proportionality mu is called as coefficient of viscosity. Here it is not equals, this is proportional. So it will become equal when you use mu into du by dy. So this mu is nothing but constant of proportionality. It is called as dynamic viscosity. This itself, tau, is proportional to du by dy, or shear stress between the fluid element layers is directly proportional to the rate of shear strain. Shear strain is nothing but du by dy. E is called as Newton's law of viscosity. Fluid which obey above relation are known as the Newton's fluids, and fluids which do not obey the above relation are called as non-Newtonian fluids. So any fluid which follows this equation, tau proportional to the du by dy while flowing, then it is called as Newtonian fluid. If any fluid which does not obey this equation, tau is equal to du by dy, tau proportional to du by dy, then it is called as non-Newtonian fluid ಅಂತ ಹೇಳ್ತಾರೆ. So these are the two types of broad classification of the fluids based on the Newton's law of viscosity. Okay, so now in the next topic section, so we will study what is the variation of the viscosity with respect to the temperature or with the temperature. So this one you are going to conduct some experiment also in the 5th semester in the energy conversion laboratories, how the temperature of the fluid varies with how the viscosity of the fluid varies with the temperature. Okay, now you see this figure. So what happens as the temperature increases along with the x-axis? For liquids, viscosity is decreasing. Now the same is not true for the gases. As the temperature increases for the gases, the viscosity of the gas increases. It is gas shows exactly opposite behavior to the liquids. So this is a very well-known thing. When you heat a liquid, means a oil, let us say oil, so oil will become thin. Okay, so when you cool an oil, then it will become thick. Therefore engine oils are exposed to the certain engine temperature. When the engine is running, the oil will become thin, it flows very easily. The same thing when the engine is stopped, gradually the engine returns to the normal ambient temperature and the oil will become thick. So this is true. Not only this one, in the cooking oil, when it is heated, it will become very thin, it flows very easily. But when you stop cooking or when you turn off the gas knob, gradually it returns to the normal temperature and it will become thick. The coconut oil what you use for your hairs, so you might have observed in the winter, because of the cold temperature it will become very thick, it will not flow easily. So in order to make it flow, what we generally we put it in a hot water bucket, so that the temperature of the hot water will be transferred to the oil and oil will heated up. Okay, so the warm oil will be easier for flowing. Okay, so this we have done the experiments already in our daily life, so that's what we are studying now. Okay, now so the liquid, the same thing. Why in the liquids, after temperature increases, the dynamic viscosity decreases? That explanation is given here. So in the liquid, and again in the any fluids, whether it is a liquid or gas, there are two types of forces. One is cohesive force between the molecules, and another one is molecular momentum transfer between the molecules. In air and in gas and liquid, in both we have two predominant forces. One is cohesive force. Cohesive force means these are the forces which hold all the molecules together. These are the bonding forces. And molecular momentum transfer, molecular momentum transfer is nothing but it is a force by means of which the molecules tend to move from one part to another part in the liquid. Here, after heating liquids, what happens? You see that cohesive forces between molecules reduces. So this cohesive force will be down, they reduce, and molecular momentum transfer increases. So the bond between two molecules reduces, okay, and molecules will become free and molecular momentum transfer increases. When molecular momentum transfer increases and force of attraction decreases, then what happens? The liquid will become thin and it can be easily flow. Therefore, the viscosity will reduce. So this is the reason. So cohesive force decrease, molecular momentum transfer increases in liquids. Therefore, dynamic viscosity of the liquids decreases as the temperature increases. This is the graph. Okay. Now, for liquids, we can have this equation mu is equal to mu naught divided by 1 plus alpha t plus beta t square. So, where mu is what? Density of the sample oil or liquid. Mu naught is what? At 0 degree Celsius, what is the viscosity? Mu is what? Viscosity at given a temperature T degree. Alpha and beta are constants. See, viscosity is not constant always. It depends upon the temperature. For example, at 25 degree Celsius, if I ask you to calculate a particular viscosity, then you have to use this equation. So what is the viscosity at 0 degree Celsius for that sample oil? That you have to substitute here. Alpha and beta constants, temperature in degree Celsius you have to substitute here. Then you will get viscosity at that 25 degree Celsius for that liquid. Okay. So for water, this is a standard fluid viscosity at 0 degree Celsius is mu naught. Water 1.79 into 10 to the power of minus 3 poise. Now you see that again he has expressing the value in terms of poise. So poise you have to poise you need to convert to Newton second per meter square. Okay, so this is the SI unit of the dynamic viscosity. Alpha and beta are constants, so that value also they have given here. Now the similarly gases also we have some explanation. As I told you, two types of forces, cohesive forces and molecular momentum transfer. Two types of forces are there, both in the liquid as well as in the gas. So here in the previous one, what happened? So cohesive forces are reduced, molecular momentum transfer increases. Now in gases, after temperature increases, the cohesive forces here it has reduced. Now here the cohesive forces increases for between the molecules and molecular momentum transfer decreases. Cohesive forces increases means you have a better bonding between molecules of the gases, and molecular momentum transfer decrease means you cannot see or observe free molecular momentum transfer. So molecules will have some resistance for their motion in the gas. So in that cases, attractive force increases, momentum decreases means the dynamic viscosity of the gas what happens increases means gas cannot flow easily. Therefore, in this case, for the gases, what happens as the temperature increases, the viscosity also increases. Okay. Now again, we have an equation to calculate the gas viscosity at a particular temperature. Now mu is equal to gas viscosity at a particular temperature. Mu naught is nothing but a given gas equation at 0 degree temperature, 0 degree Celsius. Alpha and beta are constant for the gas. T is the temperature. So the value of alpha and beta are given. So for air is a standard fluid for the in the gaseous form. For that mu naught is 0.00000017 poise. Again it is in poise that you have to convert it into the Newton second per meter square. Okay, So this is the explanation for the viscosity. In the viscosity, we have studied two types of viscosities: dynamic viscosity, kinematic viscosity. Dynamic viscosity unit in SI unit is Newton second per meter square. CGS unit is Poise. Kinematic viscosity unit SI unit is meter square per second, and CGS unit is Stokes. Okay, so conversion also I have told. Newton's law of viscosity we have discussed. Tau is equal to mu into tau is equal to mu into du by dy, or tau is proportional to du by dy. Shear stress is proportional to the rate of shear stress. Next, variation of liquid and gases viscosity with respect to the temperature, and corresponding equation to find out the viscosities at a given temperature for both liquid as well as gases also we have discussed in this class. Okay, so now this is one problem. So are you ready with a pen and paper, all of you?
Yes, sir.
Okay, take down this problem then. ಕಾಣಿಸ್ತಾ ಇದೆನಾ ಪ್ರಾಬ್ಲಮ್? Density of the liquid is 837 kg per meter cube, and kinematic viscosity is 1.73 Stokes. Find its specific weight, specific gravity, specific volume, and coefficient of viscosity. Okay, so this is what they have given. ಏನೇನು ಕೊಟ್ಟಿದ್ದಾರೆ? Density. They have given density of the liquid. They have told liquid ಅಂತಂದು ಕರೆಕ್ಟ್ ಆಗಿ ಓದ್ಕೋಬೇಕು. ಲಿಕ್ವಿಡ್ ಅಂತ ಓದಿದಾಗ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಫ್ಲೂಯಿಡ್ ವಾಟರ್ ಆಗುತ್ತೆ. ಮತ್ತೆ ಕೈನಮೆಟಿಕ್ ವಿಸ್ಕಾಸಿಟಿ they have given. ಕೈನಮೆಟಿಕ್ ವಿಸ್ಕಾಸಿಟಿ ಯಾವುದು? ನ್ಯೂ 1.73 ಸ್ಟೋಕ್ಸ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ. ಓಕೆ, ಸೊ ಯು ಫೈಂಡ್ ಅ ಸ್ಪೆಸಿಫಿಕ್ ವೇಟ್. ಸ್ಪೆಸಿಫಿಕ್ ವೇಟ್ ಏನಾಗುತ್ತೆ? ಗಾಮಾ. Specific gravity, capital S. Specific volume, small v. Correct? Specific volume, small v. Coefficient of viscosity andre mu matte mu. Sorry, coefficient of viscosity andre mu ashte. Already kinematic viscosity kotane. Coefficient of viscosity andre now tau is equal to mu. Tau is proportional to du by dy ಮಾಡಿ ಆಮೇಲೆ coefficient ಆಡ್ ಮಾಡಿದ್ವಿ. ಆ coefficient nothing but mu. Mu is nothing but dynamic viscosity. ಸರಿ ಇದನ್ನ ಅರ್ಥ ಆಯ್ತಾಗಿದ್ದು? ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಇಲ್ಲಿ ನೋಡ್ರಿ. ಈಗ ಡೆನ್ಸಿಟಿ ಕೊಟ್ಟಿದ್ದಾನೆ. ಎಷ್ಟಪ್ಪ? 837 kg per meter cube ಅವನೇ ಹೇಳ್ಬಿಟ್ಟಿದ್ದಾನೆ. ಸೊ ನೀವೇನು ಕನ್ವರ್ಟ್ ಮಾಡೋ ಅವಶ್ಯಕತೆನೇ ಇಲ್ಲ, ಡೈರೆಕ್ಟ್ ಆಗಿ ಅವ್ರು ಕೊಟ್ಟಿದ್ದಾರೆ. ನೆಕ್ಸ್ಟ್ ಏನ್ ಕೊಟ್ಟಿದ್ದಾನೆ? ನ್ಯೂ ಲಿಕ್ವಿಡ್ ಅಂದ್ರೆ ಕೈನಮೆಟಿಕ್ ವಿಸ್ಕಾಸಿಟಿ ಆಫ್ ದ ಲಿಕ್ವಿಡ್ ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾನೆ? 1.73 ಸ್ಟೋಕ್ಸ್ ಅಂತ ಕೊಟ್ಟಿದ್ದಾನೆ. ಸ್ಟೋಕ್ಸ್ಗೆ ಇದು CGS ಯೂನಿಟ್, ದಟ್ ಯು ಹ್ಯಾವ್ ಟು ಕನ್ವರ್ಟ್ ಟು SI units. Okay, so 1 Stoke is equal to 1 by 10,000 meters per meter square per second, athwa 1 into 10 to the power of -4 meter square per second. So that conversion I have told. 1 Stoke is equal to 10 to the power of -4 ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಪರ್ ಸೆಕೆಂಡ್ ಅಂತ ಕನ್ವರ್ಷನ್ ಇದೆ. ಸೊ ಈಗ ಏನ್ ಮಾಡ್ಬೇಕು? 1.73 ಮಲ್ಟಿಪ್ಲೈಡ್ ಬೈ 10 to the power of -4 ಮಾಡಿದಾಗ ನಿಮಗೆ ಸ್ಟೋಕ್ಸ್ ನಲ್ಲಿ ಇರೋದು ಕೈನಮೆಟಿಕ್ ವಿಸ್ಕಾಸಿಟಿ ಯೂನಿಟ್ ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಪರ್ ಸೆಕೆಂಡ್ಗೆ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ. ಸೊ 1.73 into 10 to the power of -4 ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಪರ್ ಸೆಕೆಂಡ್. ಸೊ ಇದನ್ನ SI ಯೂನಿಟ್ ಗೆ ಎಲ್ಲವೂ ನಾವು ಸಾಲ್ವ್ ಮಾಡೋದ್ರಿಂದ ನೀವು ಸ್ಟೋಕ್ಸ್ ನ ಕೂಡ SI ಯೂನಿಟ್ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೋಬೇಕಾಗುತ್ತೆ. ರೈಟ್. ದೆನ್ ಫಸ್ಟ್ ಏನ್ ಕಂಡುಹಿಡಿಬೇಕು? ಸ್ಪೆಸಿಫಿಕ್ ವೇಟ್. ಸ್ಪೆಸಿಫಿಕ್ ವೇಟ್ ಅಂದ್ರೆ you see that gamma liquid. So gamma is the term letter used for the specific weight. Gamma liquid you have to find. Next, specific gravity, capital S. Next, specific volume, small v. Coefficient of viscosity, mu. 4 term ಕಂಡುಹಿಡಿಬೇಕು. ನೆಕ್ಸ್ಟ್ ಸ್ಪೆಸಿಫಿಕ್ ವೇಟ್ ಹೆಂಗ್ ಮಾಡ್ತೀರಿ? ಏನೇನಿದಾವ್ ನಿಮ್ಮ ಹತ್ರ? ಇರೋದು ಏನಂದ್ರೆ ರೋ ಇದೆ, ನ್ಯೂ ಇದೆ, ರೋ ಇದೆ, ನ್ಯೂ ಇದೆ. ಸೊ gamma find out ಮಾಡಬೇಕು. So it is very easy to find out gamma because you know this standard equation, gamma liquid is equal to rho into g ಅಂತ ನಿಮಗೆ ಗೊತ್ತು. ಆಲ್ರೆಡಿ ರೋ ಇದೆ, g is the acceleration due to gravity. So rho 837 kg per meters cube, acceleration due to gravity 9.81 ಮಾಡಿದಾಗ ನಿಮಗೆ ಏನ್ ಬರುತ್ತೆ? Specific weight of the liquid 821097. ಸೊ ಯೂನಿಟ್ ರೋದ್ ಏನಿದೆ? kg per meter cube ಇದೆ, ಕರೆಕ್ಟಾ? ಇದು ಆಕ್ಸಿಲರೇಷನ್ ಗ್ರಾವಿಟಿ ಯೂನಿಟ್ ಏನು? ಹೇಳ್ರಿ ಯಾರಾದ್ರು. ಆಕ್ಸಿಲರೇಷನ್ ಯೂನಿಟ್ ಏನು? ಕೇಳಿಸ್ಕೊಂತ ಇದೀರಾ? ನಿದ್ದೆ ಮಾಡ್ತಾ ಇದೀರಾ? ಆರಿಫ್ ಇಲ್ಲ. ದೀಪಕ್?
Yes, sir.
ಹಾ, ಆಕ್ಸಿಲರೇಷನ್ ಯೂನಿಟ್ ಏನು?
Sir.
ಹಾ, ಆಕ್ಸಿಲರೇಷನ್ ಯೂನಿಟ್ ಏನಪ್ಪ? ವೆಲಾಸಿಟಿ ಯೂನಿಟ್ ಏನು?
Velocity.
ಸಿರಿ ಇವೆಲ್ಲ ಯೂನಿಟ್ಸ್ ಕಲ್ತ್ಕೋಬೇಕು ನೀವು. ವಾಟ್ ಇಸ್ ದ ಯೂನಿಟ್ ಆಫ್ ವೆಲಾಸಿಟಿ?
ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್.
ಓಕೆ, ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್. ಪರ್ ಟೈಮ್ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ? ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ ಸ್ಕ್ವೇರ್. ಅಲ್ಲಿಗೆ ಕೆಜಿ ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ ಸ್ಕ್ವೇರ್ will be Newton. Newton per meter cube will be the unit of the specific weight. Okay. Similarly, specific gravity. Specific gravity equation is what? Specific weight of the given liquid divided by specific weight of the standard liquid, or density of the given liquid divided by density of the standard liquid. Either you can solve this portion or you can solve this portion. Both are same. So illi given liquid specific weight 8210, okay, divided by standard liquid ಯಾವುದು? 1000 into 9.81 9810. ಎರಡನ್ನು ಡಿವೈಡ್ ಮಾಡಿದಾಗ you will get 0.837. Density consider ಮಾಡಿದಾಗ 837 is density they have given in the problem. Divided by 1000 ಮಾಡಿದಾಗ 0.837. See, both the answers are same. Both the equations are same. So you can use any of the equation. So for me, always I use this one, density, because the values and the units are convenient to me. Okay. Next one, specific volume. Specific volume is nothing but it is a reciprocal of the density, 1 over rho. Correct? Now rho is